Happy Friday. Gonna get going. Let's see. Actually, I wanna make this little guy here a bit smaller. Oops. Test. Ooh, there we go. Okay. Little tiny thing in the corner. Lovely. Okay. It looks like the last export to YouTube succeeded. Great. Give this Twitch page a refresh. Doesn't always reconnect when I leave it overnight. The old headset's on. All right. Test. There we go. Where are we going? We are going into code coverage. Oh dear, I hear myself. Why do I hear myself? Is that better? Oh, perfect. Headphones. Yay. We're going into code coverage. So I found that there are a few pages on how to set up code coverage. If you clear my search, there we go. Chapter 10, instrumentation based code coverage. That's in the Rust C documentation. Now, from there, there's also an announcement on the users group. Is that white quark? Huh. They posted how to do this years ago. And this morning, I just saw cargo LLVM coverage. I think I would like to try to test this one. Basic usage, yeah, please. Well, this looks amazing. Amazingly simple. Let's install it. Where did my editor go? There it is. I had just been installing LLVM 19, but I don't think that's needed. Which linker I'm using for these? All right. Default runs tests. Okay. Talk tests disabled by default. Run cargo run instead of cargo test. Use this sub command. Okay. Let's see, plain text or HTML options. And what about project? Does it work with workspaces? Ah, okay. Clean some artifacts. Well, this is nice. I was noticing some of those artifacts testing the other paths. Yeah, let's go ahead and run that. I was doing some of this stuff. Just taking some notes on what I want to run. Ah, you can merge them. Features A and B. Okay. I think I just installed LLVM 19. Ignoring certain files. Great. I don't think we need to do that. Oh, interesting. Does this work with stable? It seems to work with stable. Only doc tests require nightly. Well, here, let's go back here. Let's do stable. Okay, that's going to take it a good moment. Actually, it's going to have to do all the work again anyways because of this change. Okay, so we could stop the current build. Let's run it. I want to see if it supports like projects. Can I say just target this package? Oh, you can. Perfect. Info, Carco LLVM COV, currently setting config coverage. You can opt out by passing no config coverage. I will run rust up component to add. Oh, interesting. Okay. To install the LLVM tools preview. Sure, let's proceed. hope this is going to show us the branches that are not being covered. So that will give some confidence and direction for what should be tested. I wonder how recent this thing came out, this tool. See the graph at the bottom? Slowly gaining more. I am surprised. How did I miss this last time I was looking? Last time I was looking, it ended up finding some stuff that said, oh, it's only on Linux. Could see using the, uh-oh, what do we have here? Oh, it's trying to run it. I want to run the tests. I've made a mistake. Let's try running the HTML version. And we need to by default run tests. Okay. Run cargo run instead of cargo test. Use the run sub command. All right. So by not passing run, we run the tests. Fancy. And I need to pass it the -p data plane. Looks like it's going to be a fun day of compiling. Compiling. Yay. Given the output of this, where's my monodraw? Welcome, monodraw. So this is our architecture. The one that I'm interested in testing right now is data plane on the receiving side. We have a number of tests here. If this tests out all right, I wonder where we should go. This side over here. Start making changes to databases. Sending them to data archive, or do we do data archive next? It might be good to build out some of the data archive pieces. While this is still very fresh in our minds. Warning, 7 functions have mismatched data. Okay. Okay, report saved. Great. Oops, wrong one. Here. I just open it. Let's see. What do we have? Wow. Technically, this is the only one that I was trying to test. Interesting. So this code was not run at all. Cover not found. Really? Okay. Interesting that we have this information. I'm looking more for branch info. Oh, look. Oh, that's perfect. So they do show you when the try operators have not been executed. Look at that. Little zeros. Okay. So in sync databases, yeah, we're not covering much of the error cases. I did read that the match statements have funky results. So I don't understand why this is broken other than they have funky results. So if this is hit, then this must have been run. Well, this is nice. I'm pleased with this. Not having large chunks of kind of the happy path tested. It all seems to be the error cases. Error case. Errors. More error information. Errors. Continue didn't get hit. I think this is a timing thing. I think based on the Tokyo randomness with Tokyo select, this may or may not get hit. It just depends on which of the tasks gets pulled first. Errors, none. Okay. Interesting. And some of these are run 5 times, 1 time. That's interesting. the opposite of these. Well, the display I think is good enough. Enough to point us in a direction. We can see that certain functions are just never used. Checksum wasn't used. Validate checksum wasn't used. I was wondering about that. So we could clean up some code. I think at the very beginning there was some dead code as well. Oh no. Just this convert not found. Okay. Let's go check those at the bottom. Scroll down to the bottom. Let's validate this. Checksum not used. It's used by validate checksum, and validate checksum is not used. Okay. We've just increased our code coverage. So previously we were at 82.55%. Function coverage, line coverage, region coverage. Oh, I like this. This is pretty cool. I like this. I'm surprised that some of this other code has such high coverage. Like the DB checksum code. I know we're using it quite a bit, but what isn't used? So we come into lib from dir. I thought we ran this over and over again. Maybe not. DBs? Do we skip that and go straight to the constructor? Do we create a new one? Yeah, look at this. Called 28 times. Back to the lib. Need to load up new DBs in a directory as well. Do this more than once until we have a stable list. Let's just get rid of that. Bye. Okay. Move database. Oh, interesting. This is interesting because it means that we are not keeping DBs up to date. We do remove DBs in a number of places, or at least in one place I know of. So this should have been removed, unless there is a second remove function. But where would that be? Add database, yes. Get. Okay, what else do we have? Error case. Yep. Or error handling. It's all error handling. What about DB? Try checksum. Didn't we add that on purpose? We added checksum and try checksum. Ah, yes, we did not test that code. Okay. Resize didn't get called. I wonder why. Okay. So we should have called resize if the size of checksums needed to be increased. I thought it would at least come into the first line here, this if. It's here. Well, fascinating nonetheless. Why? Actually, I'm stuck on this. Why would resize? Oh, this font might be too small for most people. Why would resize get called? Or not get called? This code right here should have been called because set page checksum was called self.checksums.resize. Oh. It's not self.resize. Self.checksums.resize. Is there a self.resize in here? There is not. Well, I may have found a bug. This, I mean, it looks like we're just intending to set the array size. This is a pub function, though. All this 409 times in our tests. Okay. All right. Well, I'm optimistic that this is correct. I know we have tests down below, and this is actually tested pretty well. Load it up for DB checksum. It's pretty small. It should compile fairly quickly. Let's see. We also had Proto. Oh, interesting. The code from the test server was also included. I'm surprised that archive connection is 0 on it. Okay, but I think we could just reload here. Yes. We have some pieces that were not tested. Resize is tested. Interesting. This one's unreachable. That's expected. Unreachable. Great. Okay. Well, I can come back and touch this up. Man, I've been missing a code coverage tool in Rust for so long. I can't believe I didn't see this before. This is great. Let's go ahead and set the font size. All right. So going from that, what didn't complete? Did I just break something? What did I change? Telemetry context. And those two functions that were removed. Oh, it cannot find fromder in create checksum. Fascinating. So this function must not be run. Ah, yes. Interesting. And this used to hash the DBs as well. All right. What is this code? This is this is like my main function that I just tossed into the lib. Okay. One previous error, 5 warnings. Okay. This one, I didn't think that that one had anything calling it. Convert found. Okay. Oh, it does, but only in an error. And we weren't testing this error case. Okay. That's fine then. Do not need this. This is fine now. We'll give it a clean, let it do its thing. I'm satisfied with the coverage so far. I'll probably go back and in some free time and add some tests to, check some of those important edge cases, the error handling. At least have something in there so that it screams loudly when something bad happens. Make sure it's failing in the right direction. Okay, this is loading. We need to see what changed. Cargo changed. I added that. It didn't even seem like it needed it. Hmm. Hmm. I like the idea of working on data archive. It's necessary. Like this little box down here is a bit of a question mark. So I think data archive needs to store the data in some place where it's highly persistent. And I would like to use something off the shelf that just stores it. It's something that I can interact with, that we just shuffle data into. So as the data is coming through, it doesn't pause to save it into the solid state or whatever, to disk. Because as long as it's going through, it'll be saved, right? What could we use? Because I would like the data archive machines to be relatively stateless and have some other storage, which we do not have on here. This is my database. Oh, we could do this one. Yeah, circles are hard in ASCII. Whoa, whoa, whoa. So we have some sort of off-the-shelf storage cluster solution. And we would have this guy talking to that. Something like so. I don't think I specified yet what data archive does. All right, let's figure out what this storage cluster is. What is this? And for funsies, let's try to keep it Rust related. So what storage clusters are out there? We need to have some sort of range query. I think. Let's see, what sort of queries are being made? Let's look at data proto, source data archive. A databases request, so we need to know which databases currently exist. We need to know when new ones are created. This could just be like a fan out from. You know, this one probably doesn't have to be stored. I mean, it could. Maybe it's an event. Who knows? Database info. What do we give back for this one? Page size and the current checksum. Okay. Which data? So yeah, this is mainly for writing to disk. We need to know how big the pages are so we can kind of scatter shot a bunch of pages on a disk. The DB checksum, though, this one could be. Could this be something that we just pull from one of the others? Like from the last page? Does the database page have it? Or it could. We could store it in a different way that doesn't match this directly. But it does have the DB checksum. I think I would like data plane. When it's sending data to the data archive and it has a mutation page, it will tell the data archive this page has this checksum, and it changes the checksum of the database to this. Okay. So let's see what do we have out there in terms of clustering Rust-based databases? I know there's TIKV. Which implements TIDB. Open source cloud native distributed SQL database designed for modern applications. Strong consistency, high performance. Looks like it's being updated 6 hours ago. Okay. Releases 2 weeks ago. You just don't want to pick something that's going to be dead, right? Looks like it has some oomph behind it. Architecture, contributing license, okay. Key features. Not bad. MySQL compatibility. I like the idea of TIDB, but I wonder, do I just need TIKV? What does the API look like? There is a RocksDB within each store, and it stores data onto the disk. Oh, see it. Okay, let's see. And what is the API for this? Placement driver. Okay. Run our magic script on your system. Yay. Set up the playground, yada yada. Okay. Monitor the cluster. Use Java. Okay. Putting data in. Connect directly. Get a session, a raw client. Client does some data. Gets data. Batch get. Scan. Hmm. The action support. Okay, so simple API. I could get behind that. That seems reasonable. I like that it handles the pieces that I don't really want to build for me. Clustering pieces. I wonder how quickly it could absorb data. So I'm wondering, okay, we have batch scans, compare and swap, great. thing that I'm thinking of at the moment is how to implement the requests. Stream database updates. This is data coming straight through the other servers. But if somebody were to say, give me this database, we basically have to have a number of pages. So we need to know what the page number is, how many pages there are. And we need to collect the relevant pages for a database from a specific point in time. Doesn't feel like it's the right solution. I know we could build it with this. But maybe we need more like a LSM tree. Log structured merge trees. Updated in memory, bloom filters increase lookup performance. Embeddable key value store engine. See, this is nice, but it doesn't have the clustering ability that I would like to have. Hey, Anurag, how you doing? I like how simple this API is. I want to see scan. What am I working on? I am working on a system that I call Reverb. Reverb is a data replication system similar to LightFS. It's not using a fuse-based file system. It's a kind of integrated solution that is a proxy, a stack that wraps your application. So you end up writing an application that you host in the cloud on this system. It should use SQLite. And the system takes care of replicating data across the cluster. So we have a VFS plugin in SQLite that notifies our system of changes, replicates the change to data archive, and then to the other machines in the cluster. So your writes go to one system, your reads go to the n number of other readers, and we have like a continuous backup of your database. And that's what we're talking about right now. We've just come off of building out quite a bit of the data plane, the reader side of things. What we need now is this data archive piece. And we're talking about what to use. Excuse me, we're talking about what to use as the storage mechanism. I would like to more or less pull something off the shelf, but have data archive be mostly stateless. Is there any open source project? This is not yet open source. I don't have any plans at the moment, but that's how I start all of my projects. It's mostly just for fun and for education purposes. But I mainly just stream to kind of hang out and have fun writing code. Um, we'll have to see what becomes of this, because wouldn't mind, if this became something. Who knows? Maybe it becomes a business or something. That's a decade off, though, because I only make like an hour and a half progress every day. So we do have a bit of a proxy working. We have a VFS plugin that's 60%. I've got data plane, which probably 40%. We've implemented half of it, and now we're thinking about data archive. Data archive we've stubbed out for data plane, so we've basically implemented it for these tests. But the real version of it, I want to be like nearly stateless, like so stateless, and have the storage cluster manage the data. You have started learning Rust recently. Any recommendations? The book is always a great place to start. If so, the book always great. Rustling's course is also good too. Like these three things here, great way to start. I know that there are some other videos on YouTube that kind of either go through the Rustling's course or have their own kind of path. And so if you learn better by, kind of walking through things with kind of a virtual instructor, that's also out there. Yep, you're welcome. So I think we would need to build out our backend API. Oh yes, John Who videos, they do go a little deeper though. Right? If you're beginning, like you wouldn't want to go to some of his stuff, but he's got some really great content. Yeah. Exorcism, also a great choice. What are they doing? It's been a while since I used them. Did one of the other things like this go out of business? I did a bunch of the exorcism.io courses with Rust when I was learning. So, +1 to that. Hey, Rhionic Fire. Yeah, and it also depends on, do you have other programming backgrounds, right? You're a kernel developer in C++ or C, then you might not need certain pieces. But if you're starting out, then yeah, I think we've just touched on all that stuff. See, I don't think I'll need transactional. See, this is going to be a mostly write heavy thing. Um, so I've already done the load balancer part of this. And just to touch on it again, we're working on a system called Reverb. It's basically a new platform where you toss your application into it. Your application uses SQLite, and the framework, the stack, if you will, horizontally scales your application, splitting the writer and the readers, so that you can go from, project on your local development machine with SQLite to into production and just scale it out. And at the moment, we are talking about the archive server. What should the backing storage use? Or what should you use for backing store? And I'm looking at this TIKV clustering option. So TIKV, oh, this is the client. Let's go back to the project. Is this the project? Oh, it is. Sorry for all the scrolling. I like pretty pictures here. Let's go down to the pretty pictures. So I like the idea of having the archive server being mostly a pass-through and hold its state in something like this. So I'm leaning more in this direction, pulling something like this off the shelf and building the archive server around it. So we're looking at the archive server's API, the TIKV APIs. And here's the Rust client for TIKV. So I want to see the actual documentation. Building and testing, blah, 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 creating a PR, getting help, great. Where's the docs? What is this called? Client Rust, TIKV, cargo, TIKV client. Here we are. Choosing an API, raw and transactional. You should choose just one for your system. All right. Consequence of supporting transactions is increased overhead and coordination with the placement driver and TIKV. Okay, I don't think we're going to need transactional pieces because this is mostly going to be just additive. We're just going to dump data like page after page after page in this. And occasionally we will come back and do some compaction, getting rid of pages. Okay, so we want to know, what does the scan API look like? Transactional, no, I want raw. Scan, oh, scan and scan keys. So we have scan here, create a new scan request. Can you do a backward range? I want to go from, so we might have to do chunks going back in time. Scan keys. This is more likely what we would use. And we're thinking about, where's our code? How to implement fetch database. So imagine that you let me get the board out. Oh, well, goodness, I'm not audible. I just went and explained the whole thing. All right, take two. Oh my goodness. What was the last thing I said that you heard? I probably, cleared my throat at some point and missed the mute button. All right, here we'll go back a little bit. So imagine that there is a database. Okay, databases have pages: page 1, page 2, page 3, page 4. Since I started drawing, okay, perfect. We're going back to the beginning. So we have pages in a database. These are typically chunks on disk. In SQLite, you default to a 4 kilobyte chunk. Do we say gigabyte chunk now? That's going to take forever to get used to. Yeah, so 4 gigabyte chunks. And here we have 4 pages. SQLite is 1 base. So we have page 1, page 2, page 3, page 4. But when you create your database, maybe you just make a change to the first page because you just created it. And then you do that a couple times. Right? And then it starts to grow. And these are, changes. These are copies of the page at that time, so we can send the page to multiple machines. Oops. And then it gets to the point where your database grows. You now have 2 pages, and you keep making changes. And so these are copies of the page as it's being made. And that's what our VFS plugin does for SQLite. It looks and watches the VFS. The VFS monitors the page changes and shuffles the data out into our system. Okay, but now you've had a whole bunch of pages, right? So imagine, Europe wakes up, you have a whole bunch of new traffic, you need to scale up some of the readers because most websites, let's face it, they're not very write heavy, right? You have brochure websites, you have all sorts of websites that, yes, need to mutate a couple times a day. And then you have other kinds of websites that are changing constantly, like forums. Right? So imagine that, as this website's coming up online, it's a reader. I said website, I meant machine. As this machine comes online, it says, hey, give me your list of databases. Great. And that list comes with checksums. Then we have these checksums, and we say, okay, I need data for this database at this checksum. So we say, great. We need, funny. I'm using the redo undo buffer, and it looks like I had undone and redone some stuff. But let's say that as the machine was coming online, it got the data where that, just to the right of that 2 there. Right? It says, okay, I need the database at that checksum. Let's call that checksum 5. This is a C5 at the top. And that 1 to the right was a mutation of page 1 after you were told about the database. Okay, so we need to now go get the pages for this reader from checksum 5. So we need page number 2 there, page 3, and this page 1 over on the left. Great. Now, there's also the concern that this refers something like a forum. Right? Maybe we want to collapse this data, right? Compact it in some way so that, for historical purposes, it's nice to be able to go back, right? Say, oh, you know what? For the past day, I want 5-minute increments. I want to be able to go back to this database at any 5-minute point in time. But, for the database history, as we go back to like last year, maybe 1 day intervals is fine. So how do we do compaction? Imagine this is a 5-minute interval. Right? We would and yeah, 5-minute intervals, we would start to remove pieces. Because at the end of this 5-minute interval, we see that, okay, that's page number 1. Great. And for the second, we can get rid of that first change to page 2. And I think that's where I ended up. And you told me that I wasn't audible. Thank you for that. I really appreciate that. I do that more than I would like to admit. It's a couple times a week, probably. So yeah, if I'm ever quiet for more than about, 30 seconds, let me know. All right, so given this, right, how would we organize our data in the key value store so that we could do all of this? It seems like we have a couple of pieces that we need to be able to look for. We need to be able to scan based on time. This feels like these elements are timestamp, boom, boom, boom. And so we need some way to look up the actual page data. And maybe we organize it by page. So yeah, ooh, let's go back to the docs here. There's nothing that says we can't have, or is there? Let's look at the documentation. TIKV client. How many stores can we have? Can we have a store per page? So make a client. Is it just like a massive bucket? Distributed transactional key value database written in Rust. Let's connect to a TIKV cluster. Okay. We're going to use the raw client, most likely. I doubt we need to use the transaction client. The lowest level of abstraction is create and send gRPC messages. Okay. In between these levels of abstraction, you can send and receive individual messages to the cluster. Resolving data to regions. Okay. Using an API. Okay. When it is possible to use both APIs at the same time, doing so is unsafe and unsupported. Love it. Reduced coordination overhead, but lacks transactional abilities. That's okay. We're not going to have two servers writing the same page at the same time. There will only be one, and that will be handled outside of this. I think we can protect against instances where we might have a problem. General flow, okay. Sync commands using the client. So yeah, you just connect and start to interact. Oh, mod back off is a module? Tell me more. When a request is retried, we can back off for some time to avoid saturating the network. Great. Codec raw lowering. What is this? Okay. Request transaction lowering. These sound like they're Yeah, therefore getting down into the protobuf pieces. Okay. Fig. What's in here? Ooh, certificates. Love it. The key part of key value pair. Great. KV pair. Now, how large? What about value? Do we have a value? Type aliases value. Value part of the... Okay, it's just a vector of U8s. So it's something that can go into value. We have value. So anything that can go into a vec of U8. All the things. Ooh, bytes. Nice. Okay. So how do we want the storage cluster to store things? Sorry, my phone buzzed. Yeah. All right, we're back. We got about 10 minutes. Let's kind of design this out. Figure we'll kind of build this out on the right here. What do we want this to look like? Just going to use this as a text element. Alignment left top. Thank you. So since this is just a giant bucket, we probably need some sort of namespacing, like page. And this, let's see. So we say page underscore. Oh, we need the database name in here too, don't we? Oh, interesting. So maybe a DB name. We have to namespace these. Page. We have whatever the page number is. Then we could have the time. That's not granular enough. Something like this. And with a scan, this would let us scan by time for a database. This would just differentiate in case there were multiple in a single second for a given page. I like that we can scan for pages by time, we can know that information about a database. Let's say we have DB name info. And this could have data about this at certain points in time. Not sure yet. Maybe that's like a high level, most recent. Maybe we also have DB name info at DB checksum. That would be, we would create one of these for every change to the database. I don't really like that. Okay. Maybe we store that with the page data. This is one way of doing it. Another way of doing it would be by transaction. And SQLite, basically using the WAL, the wall logs, they get checkpointed and have transactions inside of them, so that if the application dies mid-transaction, SQLite knows how to recover. Right? It knows how to not commit certain pieces that may be part of a fragment of a transaction. So we could also do this by transaction. So maybe we have DB name, transactions, and that points to certain things. Something like that. So we can always find them based on time. Okay. Definitely going to have to think quite a bit about this. I'll keep mulling over it. Mostly going to want to kind of design it from the point of view of how the data is going to be used by Data Archive, right? And mostly by the readers and getting snapshots of databases. Imagine this is like short-term storage. And then, oh, did that not save? Oh, it's just not large enough to display. Then we have a slow one. And this would be like S3. or something that's S3 compatible. All right. Let's figure out who we want to raid today. Any suggestions? See, I'm the only one doing Rust right now. Let's raid Fullbox. He's doing some Godot. I do have a soft spot for Godot. All right, y'all. Well, thanks for hanging out. Appreciate the company and the questions. Well, until next time. Bye-bye. What's BQN? I'll have to take a look.